Problem number 47 from homework 2.5 day 2. In this problem, we are given the graph of a function and we're asked to write the equation. So the first thing that I like to do is identify the parent function. The parent function here is y equals x squared, because this is the graph of a parabola. And I'm going to sketch a few points on the parent function. So that would be 0, 0, 1, 1, negative 1, negative 1, and 2, 4, 1, 2, 3, 4, and negative 2, 4, 1, 2, 3, 4. So this is the graph of the parent function. And now I'm going to record the transformations that I see. So the first transformation that I see is that this graph is reflected in the x-axis. So that's a transformation. To get a reflection in the x-axis, we have to multiply the whole function by negative 1. So my new function, let me call it g of x, is going to be negative in front, and then I'm going to have x squared. But let's figure out the other transformation before we write the equation. So this reflection in the x-axis means I have a negative in front of my function. And then what else is going on? This graph looks narrower than the original function, so we can think of that as a vertical stretch. Okay, by how much has this been stretched? Normally, if I just reflected it, I would be at 1, negative 1 with just the reflection, but I'm at 1, negative 3. So this is a vertical stretch by a factor of 3. In order to incorporate that vertical stretch by a factor of 3, I need to multiply my y values by 3. So this function has the equation negative 3x squared. Let's do the second, part B. The parent function for this graph is also y equals x squared. So I'm going to go ahead and put some points from the parent function here. 0, 0, 1, 1, 2, 4. And negative 1, 1, and negative 2, 4. 1, 2, 3, 4. So those are points on the parent. This has the same parent function, so I'll write that up here. The parent here is y equals x squared. And I put some points on here. So what's happened in this graph? The vertex has moved up 3. So it looks like I have a transformation moving this up 3 units. So that means I need to add 3 to my y values. But what else is going on? It's not solely up 3. This graph also looks narrower. So normally, if I shifted my parent function up 3 units, I would have 0, 0 goes to 0, 3, but 1, 1 will go to 1, 4. So we can see normally we go right 1 and up 1 on the parent function. But now we're going right 1, and instead of going up 1 to 1, 4, we're going right 1 and up 4. So because we're going right 1 and up 4, we have a vertical stretch by a factor of 4. So to put in a vertical stretch of a factor of 4 and a shift up 3 units, this equation would be y equals 4x squared plus 3. Some of you may also see this as a horizontal shrink. And you can see that normally if we go up 4, like we're doing here, we would go right 2, right? In the parent function, the point is right 2 up 4, but now we're going right 1 and up 4. So this could be also thought of as a horizontal shrink by a factor of 2, and that would be y equals 2x inside the function squared plus 3, but these are equivalent. Okay, so you can think of this as a vertical stretch by a factor of 4 or an equivalent horizontal shrink by 1/2. I think it's a little easier to see the vertical stretch, but either one works perfectly well.